All right, friends and neighbors, welcome back to another CCNA networking video. Today we are covering Chapter 8, DHCP Snooping and Dynamic ARP Inspection. Now, as I go through this, we're not there yet, but we're getting near the end of this whole CCNA journey. So, hey, put in the comments down below, maybe the next journey we ought to take. What's the next cert we ought to tackle? What's the next topic? But for right now, we're going to be doing DHCP snooping and ARP inspection. So we'll talk about the key topics. Our exam section for this one is layer 2 security features. So everything that we do will be on a switch. And in particular, this time we're going to talk about and demo dynamic ARP inspection and DHCP snooping. So we'll talk a little bit about how those work again, but really we'll dive into the logic behind them, and then implementation. And of course, previously we did port security, and then we'll finish up as always with the "Do I know this already?" questions. So the key topics, we'll start off with DHCP snooping, and so we'll remind ourselves quickly how DHCP works, and then we'll take a look at the issue associated with DHCP, and then figure out how to protect ourselves a little bit. So that'll be the snooping part. It turns out that a switch can keep track of all of the DHCP data, and then so we'll talk about the configuration and the implementation. The second part of this will be the ARP inspection, and so it's also called dynamic ARP inspection. And so in this one, we'll talk again, remind ourselves about some of the ARP messaging and some of the addressing, and then we'll learn how bad guys can exploit that and then what to do about it. So again, we'll be doing a configuration and an implementation. So when we talk about DHCP snooping, right, this is a lot of extra effort. What's the real issue? What's the problem here? Well, a host will learn everything they need to know from a DHCP offer, which also means that if you're a host and you're in an unsecured, or I'll say unencrypted network, right, you're waiting for these offers. So you do the discover with DORA, then you're waiting for an offer to come in. Now, the offer actually has all the information for a particular network. And so if you look at the packet right above me here, this is a basic configuration. No VoIP, no extra servers or anything else. But you can see that the servers listed there, how long leases are for, the mask, an IP address, any other servers that might be acting as relay agents, the router, the DNS, all of these are part of a DHCP offer. And what that means is that anyone listening to this network, particularly in the case of wireless, right, this is a broadcast frame. You can see right here, this is broadcast addressing. And at layer 2, it's also broadcast addressing, which means that it gets blasted everywhere, at least on that VLAN or subnet. So an attacker picks these up and can learn everything about your network as well. But worse, an attacker can act like a DHCP server themselves, and so give you bad information and act as a man in the middle. So there's a whole bunch of problems that result from having this sort of clear text DHCP dynamic host configuration protocol out there. So what do we do about it? Well, the switch, it turns out, when we turn on DHCP snooping, can act sort of like a firewall in that it chooses to permit or deny DHCP messages, and then the other traffic is left alone. Remember that this is very specific to DHCP traffic. So what ends up happening is the switch is listening in on DHCP conversation, and it learns where the server is, or you tell it that the server is trusted, and then it learns what MAC addresses received what IP addresses. And so now all of a sudden the switch understands the correct locations of this traffic. And if this traffic appears anywhere else, then the switch blocks it. In addition, the switch is also aware of where the server is. And so any other server that pops up there can also have its messages blocked. So in that way, it prevents hijacking of clients. So we'll start off with a big idea here. Ports are either trusted or untrusted. Most of the time, we're going to trust routers and servers. And then we'll untrust clients or links that we're not really sure about. Most ports connecting to hosts will be untrusted, and so you have to make the decision to trust a port. If a port is untrusted, then the server messages are discarded on that port. So any server message that appears, like an offer, then it is automatically discarded by the switch. Client messages might be discarded if they don't match what the switch thinks is supposed to be going on. And so the binding table becomes important to us. And just at the bottom of the slide here, we've got a reminder about how DHCP works, right? So initially, all of this is broadcast destination, and we remember that hosts start the process with 0.0.0.0 as their source IP address. And so this conversation goes on with discover, offer, request, acknowledgement. That's the DORA. And we can see that in this particular case, all of the messages are also tied together with a transaction ID, also important if you're studying DHCP. But there's our messaging, and what we're looking for is aberrations in this messaging. So let's talk a little bit about an example attack and some of the logic that we're going to be dealing with. So above me here, we can see our attacker rogue DHCP server. So what ends up happening is that a host sends out a discover message. And if there's more than one server out there, the host will simply accept whatever offer comes first. Maybe the attacker doesn't get everybody, but it gets a couple of nodes. Here's the twist. The attacker gives out perfectly valid information to the host because we don't want, as an attacker, to disrupt the host transmission. That becomes, sort of a flag or makes it obvious that an attack is underway, or at least a problem is out there. So what the attacker does instead is advertises itself as the gateway. So when the client wants to go off the network, it sends the traffic to the attacker. The attacker then forwards it to the correct router, and then the router forwards that traffic back to the attacker. And the attacker then is what we call a man in the middle. This attack can also work closely with an ARP poisoning attack, which we'll talk about later on. But at a minimum, a host could be given bad information from an attacker, and then it's a simple denial of service, right? The host can't get anywhere. You might even give it an IP address, but a bad router or no router, in which case the host thinks that it's got an IP address, but it can't go anywhere off of the network. So with DHCP snooping, the DHCP server that's attacking would be shut down. These messages would not be allowed because they would appear on an untrusted port. For clients, if they don't match what the switch thinks the MAC addresses ought to be, then that traffic is also blocked. Now beyond DORA, right, there's the discover, offer, request, and then acknowledge, there are the release and decline messages. And so these messages can also come from an attacker to tell a host that you're done, or that you can tell the server that these addresses are now released and can be given to somebody else. These messages would also be blocked by DHCP snooping. So a quick reminder about some additional DHCP addressing. In the messaging, the MAC addresses appear more than once. So here we can see that this is the layer 2 part of the frame. So this is Ethernet, and that is the source MAC address. And down here, the client's MAC address also appears because the DHCP server is going to put this together with the IP address in what's called a binding. So the MAC address and the IP address get tied together. Now in the DHCP release message, which is also a concern here, what the IP address says is, or a host with this IP address says, is, well, look, I'm done. I'm going to shut down now, or I'm going to leave the network, or I'm going into power save, whatever it is, that I, with this source IP address, I'm going to release this IP address, meaning mine. So the server says, cool, I could give this to somebody else. Well, what if a bad guy does that? Well, all of a sudden, the host is now out of luck as far as an IP address. So that's just a quick reminder about how our IP addresses appear in more than one place, and our MAC addresses appear in more than one place in DHCP messaging. All right, let's talk a little bit about DHCP snooping configuration. So what we're going to do first is enable DHCP snooping globally. And then if there are VLANs, you can specify that you're going to be doing DHCP snooping on a particular VLAN. And then we'll label the ports as being either trusted or untrusted. And then we'll go through a couple of the show commands that show us what we can do. So here's a sample config. This is the one that we'll probably build in our demo. So we're going to turn on IP DHCP snooping and then also on the VLAN. And then down on an individual port, we'll either make it trusted or we'll leave it as being untrusted. Now, there is another option that's out there, or another detail to remember, is that when there are relay agents in place, then the information field that appears in DHCP messaging can be populated. Now this is a warning for DHCP snooping, so a lot of times we'll turn this off if we're sure that there's no relay agent out there, and I'll show you what that looks like. But first, let's take a look at our demo. Okay, here is our topology that we're going to fool around with a little bit here. So what I'm going to do is on this router, I'm going to build a DHCP server. So we'll see that it won't take very long, but it'll also be good review for us. And then we've got our DHCP clients out here, and then we've got a rogue DHCP server. So first up, we'll build our DHCP server that we're going to use. That's the valid or good DHCP server. So what we're going to do is we'll make this, so we'll make it easy, 192.168.1.254. There we go. And we've already no-shutted this. And so what I'm going to do now is build the DHCP server part of this. So remember that it's IP DHCP, DHCP pool test. And then we'll say network 192.168.1.0, 255.255.255.0. Now, if we take a look at all the options that we have here on this basic configuration options in Packet Tracer, we'll add a default router, 192.168. Let's see, what did I make the server? I made the server 254, so I'll make the router 253. And just for fun, we'll make the name server 252. Now, it doesn't really matter. We're not interested really in the DHCP part of this. We are interested in the DHCP snooping part of this. Okay, so that's the router. And what should happen then is that when, oops, let's do this too. Now I'm going to just add 2 ports to my VLAN here to start with. So we'll say no to a default configuration. So we've got a couple of ports here, port 1 and 2. And for right now, I'm just going to put them in the VLAN so that we can see what happens. So I'm going to say interface. Don't really need the range command here, but I'll use it anyway. F0/1 to 2. Switch port access. VLAN. And we'll just use 101. If we take a look at, so these two just went amber. And maybe what we'll also do is to speed things up, we'll say switch port, well actually we'll do spanning tree port fast, that'll bring them around. So that makes them go forwarding much quicker. Well, let's take a look at our host here, and we're going to go DHCP, there we go. And we'll see what IP address we got. Oops, there we go. So this PC is now 1.1, and maybe what we'll do is we'll say 192.168.1.1. We'll add, this is 192.168.1.254. And just to be clear, 192.168.1.253. Okay. All right. Well, what do we know? We know where the DHCP server is. So what I'm going to do, well, I'm going to get out of the range command. I'm going to say int f0/1. Well, actually, we'll do the global commands first, right? So we're going to say IP DHCP snooping. And then I'm going to say IP DHCP snooping and we'll look at our options here. So what I'm going to do is go with the VLAN 101. Now we have a couple of other options here. We wanted to talk about the fields that we didn't want to allow. This is where we would do it, one of the places. But what we're going to do now is we're going to say int f0/1, and I'm going to say IP DHCP Snooping. And what are my options on the port? Limits we'll talk about later on, but what I'm going to do is say trust, because this is my DHCP server. All right, at this point, what I'm going to do is point out that this also means that the rest of the ports are untrusted. All right, if I want to take a look at what I've done so far, I could say show IP DHCP Snooping, and we can see a couple things here. One is that it's enabled on a particular VLAN, and that I've got a couple of ports here that are involved. One is trusted. And now insertion of option 82 is enabled. And this is what we were talking about if we wanted to restrict what our messaging was going to be. This is a question whether or not you have a relay agent or not. We're not going to worry about that right this second. Option 82 on untrusted port is not allowed. Now, the ports that were not trusted are automatically untrusted. If I take a look at my VLANs, you can see that I've only put a couple of ports in VLAN 101. So what I'm going to do is add the rest of the ports that we're working with here. So we're going to say interface range, and we'll do the rest of them. 0/2, I don't know, we'll go to 8. And I'll say switch port access VLAN 101. So what I've done is just put a whole bunch of folks in this VLAN. Now I've enabled DHCP snooping on all of this particular VLAN. And we can see that we've gone amber here, which means that the ports have gone down and they come back up because they changed VLAN. And on the PCs, we'll say, well, look, we want you to be DHCP. Now they should pull DHCP addresses. Okay, so let's review what we got here. We have a DHCP server sitting right here. And then we've got these clients, and what I've just done is added ports into VLAN 101. Now, because we don't have a DHCP relay agent, what I'm going to want to do is add here. Let me see, I may have already added, but I'll show you what I added. So we're going to do we're going to say no IP DHCP snooping. And this is where we say we don't want to use that informational field, because that's what a relay agent would change, but we're not doing that here. Information includes option, sorry. So now what should happen is that these PCs are pulling IP addresses. So that's what we have. Now, I was futzing around with some other machines here, but what we really want to realize before we see what happens when we've got a rogue DHCP server is that if we take a look at, oops, we're going to need the show command here. All right, IP DHCP snooping binding. Okay, so right here, these are the rules that the snooping part of the switch logic is going to go by. So what the switch understands is that these MAC addresses live on a particular port, and they receive these IP addresses via DHCP. So these are the bindings. So if the switch sees anything outside of this, then we are not going to allow that to happen. So that is to say, we're not going to have any confusion between the nodes. In addition, because we're not trusting any port but the DHCP server port, that when this rogue DHCP server tries to get involved, it's also going to be shut down. Okay, so I have to admit the packet tracer implementation of snooping is just a little off. It doesn't show us everything we want to see. But let me tell you what I did. So I turned off the port for our valid DHCP server. And what that means is that the hosts can no longer get DHCP ports here, or DHCP addresses. And I have a rogue DHCP server here. So let me show you the config here. So a couple things about this configuration, right? It's our basic pool with a range of addresses available, and then the default router set to itself because this is its IP address. All right, so theoretically, all of these hosts ought to be able to pick up an address from the rogue DHCP server. If we take a look at what it got, well, it just did a 0 config or a PIPA address. It could not pull an IP address. In fact, when we look at the addresses on the other nodes, they also were not able to get an address here. You can see that they've got 169s as well. If we look at the simulation, we can see the DHCP messages are going out, but they're not being answered by anybody. The only thing that we have to go by is that this port is an untrusted port as far as DHCP snooping goes. And if we take a look at the bindings, there are none, which again makes us realize that the rogue DHCP server was not able to give addresses to anybody and begin its attack on the network. And that all goes down to the DHCP snooping not trusting the port to which the rogue DHCP server was connected. All right, we'll talk a little bit more about some of the limits that we saw here, but I think that's about all we can do with the DHCP snooping demo. All right, now that we have our arms wrapped around the key ideas behind DHCP snooping, let's talk a little bit about dynamic ARP inspection, or DAI. So here's the basic problem, right? So ARP has certain behaviors. So we know that when you're looking for the MAC address for another node so that you can send it an Ethernet frame, you send out an ARP request, which is a broadcast frame that goes everywhere. And then in response, the recipient, or the node with the MAC address that you're looking for, the one that owns the IP address, says, oh, here's my MAC address, and it's a unicast message back. So this is shown to you in the two messages right here in the middle of the screen, right? So that's what a basic exchange looks like. Now, what happens if a node changes its IP address or changes its MAC address? Well, somehow we want to let nodes know that I'm alive and well out there, and so nodes can generate unsolicited messages to tell everybody of their changing address. We also see behavior in ARP that's related to DHCP, which is that you get an IP address that's offered to you. You can ARP for that IP address to see if you get any answer, and so that way you avoid collision. So those are some behaviors that we see in ARP just as part of normal operation. But what if a bad guy announced itself in the same way and pretended to be you? So this is where dynamic ARP inspection comes in. So what DAI does is it says, I'm going to examine incoming ARP messages on untrusted ports. So remember, in our topology, we've got a couple of untrusted ports. And what we're going to do is compare them to the DHCP binding table. Now, we'll remind ourselves what that looks like when we go back to the next demo. And also compares this to any ARP ACLs if they're present, if your iOS supports them or if you're using them. But at a minimum, what we're talking about is the DHCP binding table. Now, there can be some other things that are inspected, but at a minimum, what we're looking at is the DHCP binding table. And this is why these two things are in the same chapter together. Switches learn where MAC addresses are, or the port to which a MAC address is connected. And because we're doing DHCP snooping, we can tie the IP address with that MAC address as well. The gratuitous ARP, as a reminder, is when you announce any changes to your IP address MAC mapping without being asked. In other words, nobody said, hey, who's got the MAC address that goes along with this IP address? You just blast it out there to everybody. And so that becomes an attack vector and a potential for another man-in-the-middle attack. That is to say, an attacker might tell everybody else that it is you and place itself in the middle of all that traffic because everybody will be sending traffic to the man in the middle. So there's a lot going on this slide, so let's unpack it a little bit. Remember that before you can do anything, before you can communicate with anybody else, you first learn your IP address via DHCP. Now, if the switch is doing snooping, it now understands those details about you as well. It knows where you're physically connected, and it knows the IP address that goes along with you. So in the graphic above me here, we can see that if the switch is doing snooping, it now knows all about this particular PC. Now, the next thing that the host often does is tries to contact all of the devices that are in the DHCP messaging. So you get told about DNS and gateway, for example. That node might turn around and ARP for those destinations right off the bat. And you might ask yourself, why would you do that? And so you don't have to do it when you need to. It's an optimization strategy, but it's a very common thing to do. Now, if all of that learning, right, all of the traffic coming from PC0 in this case, and all of that ARP traffic matches what the switch sees in the DHCP snooping binding table, then everything's allowed. If anything's out of whack, then the switch will not allow it. So this happens again on untrusted ports. And then if you wanted to statically configure ARP ACLs, to statically configure the IP MAC matching, you could do that too. But usually the DHCP binding table is enough. In our configuration, all that we're going to do is say we're going to do IP ARP inspection on a particular VLAN. And then we're going to decide to trust the ports or not trust the ports. So I'll go over the config that we did, and then we'll add the IP ARP inspection. Now, there are some options that go along with the IP ARP inspection. And so you can validate the MAC addresses that are in there without doing ACLs. You can just add this command. But again, that's typically not necessary because the switch has already got the binding table. But you could add those validations in the packets if you wanted to. And then we've got, just like we have show IP DHCP snooping and the binding, we can do the show IP ARP inspection as well. All right, let's do a quick demo. Okay, so just as a reminder in our topology, we have a DHCP server up here. This is the only trusted port that we have. All of these other ports are untrusted, right? And which is why when we turned on DHCP snooping, our rogue DHCP server was not allowed to get anything done. So all of these nodes have picked up their IP addresses. And because we're doing DHCP snooping, we have the binding table that we're now going to use, right? So this shows a whole bunch of things. So I could say, right, we could do this. We could say show MAC address table, and we get some of this information. But the binding table, right, shows us the MAC address and IP address pairs, and then the port to which those nodes are connected, and then the VLAN. And how did we learn it? Right, we learned it via DHCP snooping. Okay, so what I'm now going to do is I'm going to say IP ARP, and we're going to do inspection, and we'll take a look at some of the options that we have because we're going to talk about them in another slide. So I could do the validation, and these are the validation of the addresses that are in there, but we're just going to use the binding table. And so I'm going to say we want to do VLAN 101. Now the other thing that we've also done, just as a reminder, is that we've decided which ports we're going to be trusted. And the only port that we're trusting is Fast Ethernet 01 because we know that's where the DHCP server is. Now we could also trust the port that the router is connected to, but I'm not going to worry about it right now. So where does this come into play? Now what I'm going to do is I'm going to statically configure one of these hosts to be the same address as an existing host on the network. And then I'm going to connect it to the same VLAN. And maybe what we'll do before we do that is we'll label this guy as, right, spoofing 192.168.1.3. So I'm going to go ahead and connect it to the same VLAN. So the link is up right away, and then we're going to see if we can communicate with the other nodes. Now this should cause ARP traffic to be generated. So clearly this doesn't work, and the question is why? But now before we go on to that, let's take the same node with the valid 1.3, and we'll see if this node can ping, just to make sure we don't have anything wrong with our topology. And this is the valid node that works. So what the switch is doing is comparing the ARP traffic that PC0 would have generated to communicate with PC1, or 1.1, and says, this doesn't match what I have in my DHCP Snooping binding table. And there you have it. So that is dynamic ARP inspection. Now, before we go back and finish up the slides, there's two other commands that we want to talk a little bit about. We can do a show IP ARP inspection. That'll show us what's going on. So here were a couple of the messages that were forwarded from the valid nodes. Now, if I had been doing inspection or validation of the other nodes, some of these would have failed. And then you can also pull the statistics, right? Which is very similar to the show command for the IP ARP inspection, but there you have it. So there you go. Just remember that there's a couple of commands that you can do to show what's going on with your IP DHCP snooping and your IP ARP inspection. So DHCP snooping and dynamic ARP inspection are pretty cool, but are they foolproof? And the answer is no. Both of these processes run on the switch CPU, which means that you can run the CPU out of capacity depending on the kind of attack. If an attacker knows that you're doing DHCP snooping or suspects it, or if you're doing dynamic inspection or both, what they can do is flood a switch with invalid traffic and at a minimum get you to shut down ports or prevent traffic, but you can also overwhelm a switch. Remember that a switch is a very fast device. It's doing the processing of the source and destination MAC addresses, but also the CRC. And now when we do these two tools, we're asking it to do more stuff. And so if you throw a lot of traffic at it, you can overrun the switch's CPU. Now to prevent this, what you can do is prevent an attacker from sending too much traffic by setting message limits on the amount of traffic. And when the threshold is reached, then we're not going to accept any more traffic on those ports. And what this does is protect the other traffic, the other ports. Now, in recent iOSs, this will actually do what port security does and put ports in, or has the potential to put ports in an error disabled state. And remember, to recover from error disabled, what you do first is shut down the port, and then you do a no shutdown on the port. And we talked a little bit before about how more recent iOS versions have the ability to recover themselves. And that is usually after a certain period of time where we have not received any bad messages, and then the switch will automatically bring that port back up. Now, DAI automatically defaults to using rate limits, but DHCP snooping does not. So you'll have to set those if you want to use those. Now, DAI also has a burst limit, which says, not only am I worried about getting a certain number of messages, but I'm also worried about whether or not, or can be worried about whether or not I get a certain number of messages per unit time. So there's a burst feature as well. And this becomes important to us when we look at the chapter questions. And speaking of the chapter questions, do I know this already? So an engineer hears about DHCP snooping and decides to implement it. Which of the following are the devices on which DHCP snooping could be implemented? Well, hey, this is all about layer 2 stuff. So switches and multi-layer switches can both do DHCP snooping and dynamic ARP inspection. Question number 2, layer 2 switch, switch 2 connects to layer 2 switch, switch 1. So 2 switches and a router. a DHCP server, and 3 PCs. All PCs are DHCP clients. Which of the following are most likely to be in the DHCP Snooping trust state configurations on switch 2 for the ports connected to the listed devices? Choose 2. Okay. Well, since you don't know what's downstream of a switch, that might be a good place to trust because you might have a router downstream there or other servers. And of course, we already saw that PCs are not trusted devices. So those ports would be untrusted. The other devices were not options in the question. But as we saw, we would want to trust a DHCP server as well, if that was one of the answers. Question number 3, switch 1 needs to be configured to use DHCP snooping in VLAN 5 and only VLAN 5. Which commands must be included assuming at least one switch port in VLAN 5 must be untrusted? Choose 2 answers. Well, you've got to enable DHCP snooping globally, and then you've got to enable it on the VLAN. So that was C and D. Question number 4, on a multi-layer switch, a switch needs to be configured to perform DHCP snooping on some layer 2 ports in VLAN 3. Which command may or may not be needed depending on whether or not the switch also acts as a DHCP relay agent? Well, we saw that early on, right? If you don't run a relay agent, then you're going to want to ensure that you don't do the information option in the DHCP messages. So that would be, the command would be no IP DHCP snooping information option. If you didn't do that, or you just said IP DHCP snooping information option, that would be if you were going to use a relay agent. So that was A. I know it's a little confusing, but there's a difference between what a relay agent does to DHCP messages versus a standard DHCP server. Question number 5, a switch 1 has been configured to use dynamic ARP inspection with DHCP snooping in VLAN 5. An ARP request arrives on port gig 01. Which answers describe 2 items DAI always compares regardless of the configuration? So if you did nothing extra, right, if you weren't doing validation, what do you know you're going to be doing? And that would be, you're going to be comparing the MAC addressing that you see in the ARP messages against the DHCP snooping binding table. So that was the 3 PCs that we saw in the switch binding table. Question number 6, switch 1 needs to be configured to use dynamic ARP inspection along with DHCP snooping in VLAN 6 and only in VLAN 6. Which commands must be included assuming that at least one switch port in VLAN 6 must be a trusted port? Choose 2 answers. If you're going to do dynamic ARP inspection, you have to enable that on the VLAN. And then if you need to have a trusted port, you've got to go into a port and then say IP ARP inspection trust on this particular port. And last but not least, question number 7, a layer 2 switch needs to be configured to use dynamic ARP inspection along with DHCP snooping. No surprise. Which command would make DAI monitor ARP message rates on an interface at an average rate of 4 received ARP messages per second? Okay, so this is the rate limit question, but also the burst rate. So there were 2 answers in this particular question. One is if you just set a rate limit of 4. So if I got 4 messages in a second, that would be 1, or if I got 16 in 4 seconds, that would be the same ratio. And so those 2 answers, C and D, were for question 7. All right, the Chapter 9 look ahead, device management protocols. So we're going to move away from security and get into management a little bit. Previously, we've talked about user accounts, Telnet, and SSH, but these are about layer 2 management protocols. That is to say, how can we learn more about the network? And so big topics will be Cisco Discovery Protocol, Link Layer Discovery Protocol, or LLDP, and then some syslog stuff. This is actually one of my favorite topics. How do you learn more about the network? All right, this has been DHCP snooping and ARP inspection. Recall that DHCP and ARP standard operation, right? You sort of have to understand those to understand what in the world snooping and dynamic ARP inspection are doing. And a node first has to DHCP. So before you can do anything, you DHCP, and then you can ARP for all the folks that you learned about via DHCP. So dynamic ARP inspection is taking a look at what the binding table populated and then comparing the packets. So that's the whole idea. All right, like and subscribe if you're ready for part 3. We just completed part 2. I had to change that from volume 2. And some more big ideas like management. We're going to do some QoS, quality of service, and some network address translation, which is everywhere and really helps keep us from adopting IPv6. All right. So at the beginning of the video, I asked you for some suggestions. So in the comments below, if you want to give me an idea of what you might like to tackle after we finished with the CCNA, fabulous. But no matter what we tackle next, may those packets always reach their destination. And hey, we're moving on to part 3 in CCNA Volume 2. You can do this.